Hello everyone. In this series of videos, we'll be learning how to find the last digit and the last two digits of certain products and exponents. So what I mean is, like you can see here, if you're given a product like this, 845 into 760, 675 into 912, what is the last digit of this product? And also the last digit of exponents like 31 raised to the power 72, what is the last digit, or 78 raised to the power 343, what is the last digit? And similarly the last two digits. So we'll begin with finding the last digit. Okay, for a product, it's very simple. If you have multiplication of any numbers like this, to find the last digit, all you need to do is to take the last digit of each of these numbers and multiply them and see what is the last digit of this product. So for finding the last digit of this product, what we need to see is what is the last digit of 4 into 2 into 8 into 3. Now how do we solve this? 4 into 2 is 8. 8 into 8 is 64. Now instead of 64, again we can just take the last digit, which is 4 into 3 is 12. That is, the last digit is 2. I'll redo it again so that you understand. 4 into 2 is 8 into 8 into 3. This is equal to 64 into 3, and if you solve it, you will get 192. So which means the last digit is 2. But again, just for, in the exam you need to do it quickly. So all you need to do is keep leaving out the tens digit. So just to show this again, 4 into 2, 8. 8 into 8, 64. 64, leave out the 6, just take the 4. 4 into 3 again is 12. 12, leave out the 1, answer is 2. So this is how you find the last digit of a product. Now in the exam, if you get a question like this, 81 into 82 into 83 and so on into 99, what is the last digit? Now this is more a question of presence of mind than anything else. You would understand that this is simply, the last digit is simply the multiplication of the last digits of all these numbers. And if you see, there is sitting right in between this is a number called 90 with the unit digit 0. So 0 multiplied by anything xyz is simply equal to 0, and that's your answer. So in the last digit kind of questions, please look out for these numbers which end in 0, which can obviously make your write very simple. Okay, now if you want to find out the last digit of exponents, here we are looking at exponents. I need you to see something in this which is called the cyclicity of 4. So please don't get worried by jargon. I'll show you what exactly I mean. So here I've written, this is basically powers of 2. So 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, and so on up till 2 raised to the power 16. Now what I want you to notice in this is here, the unit digit of 2 raised to the power 1 is 2. Now if I go to 2 raised to the power 5, again it is 2. Right? Now 2 raised to the power 9, again it's 2. 2 raised to the power 13, again it's 2. So what have we noticed? 1, 2 raised to the power 1, 2 raised to the power 5, 2 raised to the power 9, 2 raised to the power 13, and so on. If you do it further, you will see 2 raised to the power 17 also have the same units digit, which is equal to 2. So if you see, the difference between all these is 4. Now is this a fluke or is this some sort of rule? To check that, let us go to, let us say 2 raised to the power 2. So 2 raised to the power 2 is 4. Now 2 plus 4 is 6. Now go here, again the unit digit is 4. Then again 6 plus 4, 10, unit digit 4, 14, unit digit 4. So now we saw that 2 raised to the power 2, 2 plus 4, 6, 10, 14 and so on. Again the unit digit is coming out to be the same in all the cases. And again you can see the cyclicity of 4. Now if you see the other numbers also, you will see that this rule is not only restricted to 2, it is followed in 3, 4 and 7 etc. also. So here again we'll see, let's check 3 and let's start from 3 raised to the power 3, 27, unit digit 7. Now if I go to 3 plus 4, that is 7, again I find 7, 7 plus 4, 11, again unit digit 7. So you can just, if you haven't understood or if you are still not convinced, you can go through various cyclicities of 4 and you will see that whenever the power is basically, let us say I am having any number 7 raised to the power some power n, and there will be some unit digit. If I have that same power plus 4, then I'll have the same unit digit again. So this is basically the cyclicity of 4. Now if you have understood this, we can now use this to find the unit digits of exponents. So before I go any further, first I'll take the very simple things. If the number that is raised to the power of something ends in 0, 1, 5 and 6, then these numbers raised the power anything will give these numbers themselves. So what do I mean? If I have obviously 80 raised to the power, let us say 3, it will end in 0. Similarly, any 80 or any number which ends in 0 raised to the power any number. So let me have 1540 raised to the power 3, 6, 5, 4. Whatever it is, it will end in 0. The same is the case with 1, 5 and 6. So if I have 1436 raised by 5421, it will simply be 6. So similarly for 5 and similarly for 1. This is because you can see 6 into 6 is 6. So no matter how many 6 I multiply, I'll always end up with a 6 in the units digit, and the same is the case with 1 and 5. So this is fairly simple, this set of numbers. Any number ending in 0, 1, 5 and 6 will be, and this number raised to any power will end in 0, 1, 5 and 6 respectively. So that is straightforward. Now if you have the other unit digits like 2, 3, 4, 7, 8 and 9, then what do? We use that rule of cyclicity of 4. So what I mean is, let us say I have 2 raised to the power, let us say I have 32 raised to the power, let us say 41. So this means I can see that 41 is basically, if I divide 41 by 4, what do I get? I get remainder as 1 and this. So this means 41 can be written as 4 plus 4 plus 4 plus 4 10 times plus 1. So this means 32 raised to the power 41 will have the same unit digits as 32 raised to the power 1. Because like I said, there is a cyclicity of 4. If you keep adding 4 to 1, you will end up with 41. So this is a general rule that whatever power you have, you just divide that by 4 and you find the remainder. And once you find the remainder, you find the number raised by that remainder and the unit digit will be the same. We'll take some examples to make it clear, but I just want to point out this case where the remainder is 0. If the remainder is 0, you do not raise that number to the power 0, but you raise it to the power 4. Now let's see some examples to make it clear. So let us say I have 37 raised to the power 43. So again, let me start with 43 and let me divide that by 4. So I have remainder as 3. So unit digit of 37 raised to the power 43 will be the same as the unit digit of 37 raised to the power 3. Now like I told you, so this is 37 into 37 into 37. For unit digit, you just need to take the last digit and see the multiplication. So I just need to take 7 into 7 into 7. So 7 into 7 is 49. Again, I just take the unit digit 9 and ignore the 4 into 7. And this is 63. Again, I ignore the 6. I am remaining with 3. So the unit digit will be 3. So similarly, let me take another example. 28 raised to the power 36. Now 36, as you can see, is divisible by 4. So in this case, as I told you, if it is divisible by 4, you can't take 0. So it will be, the unit digit will be the same as 28 raised to the power 4. So again, this is 28 into 28 into 28 into 28. 8 into 8 is 64. I just take 4. 8 into 8 is 64. Again, I take 4. Unit digit is 4 into 4, 16. That is, ignore the 1. Unit digit is 6. Now, so similarly, you can take any number of examples, and to make this more clear, so let me say I have 23 raised to the power 51. 51 divided by 4, I'll get the remainder as, let me just do it. I get the remainder as 3. So the unit digit is the same as 23 raised to the power 3, which is 23 into 23 into 23. 3 into 3, 9. 9 into 3, 27. That is, unit digit will be equal to 7. So this is how you can solve the questions. You only need to remember that if you get the remainder as 0, You will not take raised to the power 0, you will take raised to the power 4. And just to remind you, this rule is valid for when the unit digit is 2, 3, 4, 7, 8 and 9. Because for the other ones, 0, 1, 5 and 6, anyways you will only get these digits in the unit digit. Okay, now let's move on to the last two digits. So again, let's start with products. So if I have numbers like this and I'm trying to find the last two digits of this product, like we saw in the case of unit digit, all you need to do is take the last two digits of all the numbers and find it out. So now 45 into 12 is 540. Basically, I will ignore this. I will just keep the 40, but let me write it down for the moment. Similarly, 08 into 13 is 104. Again, I keep the last two digits. So here I am taking this, here I am taking this. So I get 40 into 04, which is equal to 160, and the last two digits is 60. So again, to do it very quickly in the exam, what will you do? 45 into 12, you have to calculate 540. Just write 40. Forget the, so now you just take the last two digits because we are being asked that. Forget about all the other digits. Multiplied by 8 into 13 is 104. So 0, 4. Forget about the 1 and multiply this. I get 160. Forget about the 1. Answer is 60. 60 is the 60 are the last two digits of this entire product. So products is fairly straightforward. Now let's move on to exponents and the last two digits of exponents. So first let's understand when the number, this number is ending in 1. That is unit digit is equal to 1. And we're trying to find out the last two digits of this exponent. Here we have a very simple rule. You take the tens digit of this and you take the unit digit of the power. You multiply them. So 4 into 3 here is 12. The last digit, as you know, when it is ending in 1, the last digit of this entire exponent will always be 1. So I write this and the last two digits of this exponent will be 21. So again, to show it again so that it becomes clear to you, 81 into 68. Take the tens digit of this and the unit digit of the power. I have 8 into 8, which is equal to 64. 1, obviously 1 raised by anything will end in 1. So I will put this 1 directly and 41 is the last two digits. You forget about the 6. 6 is not the third digit necessarily, but 41 will be the last two digits. Now if I move on to here, again this is a 3-digit number. You can have any number of digits, but you need to take the tens digit and you need to take this, the units digit of the power. So this is 4 into 4, that is 16. Again, let me write this once and then the unit digit of this exponent will always be 1. So the last two digits will be 61. So this is how you do it. So again, quickly when you do it in the exam, so whenever you have anything, let us say I have 31 raised to the power 5, 3, 4, 7, let us say. So 7 into 3 is 21. So I have 1 and the unit digit will be 1. So the last two digits will be 11. Again, one more example. Let us say I have 1, 5, 6, 2, 5, 1 raised to the power 5, 3, 2, 4. Again, what will I have? I'll have 5 into 4, which is 20. So I'll just take the unit digit of that product 0 and 1 will be as such and the last two digits will be 0, 1. So you multiply these two and you take the unit digit of the product. That will be the tens digit and 1 will be the units digit. So I hope that these examples make this clear, because this is one of the simplest questions you can get in terms of exponents and finding the last two digits. Okay, again these are some examples. So in this case, again this is the tens digit, this is the units digit. So this is 5 into 6, 30. Just take the 0 and 1. These are the last two digits. Similarly here 6 into 8, that is 48. Just take the 8 and 1, that is this. So if I multiply these, I will get 81 and the last two digits of this, the whole expression will be 81. And similarly, if I multiply it with more terms, you just keep doing, finding out the last two terms, two digits, and multiply them to find the two digits of the expression. Now let's find out the last two digits of squares. So whenever you're given with some squares, all you need to do is to take the base of either 50 or 100. So what I mean by this is, so whatever number you are given, like in this case 56, you express this in terms of either 50 plus something or 50 minus something, and 100 plus something or 100 minus something. So in case of 56, it is simply 50 plus 6 raised to the power 2. Now once you express this like this, the rule here is that the last two digits of 56 raised to the power 2 will be the same as the last two digits of 6 plus 2 here. So 6 raised to the power 2. 6 raised to the power 2 is 36, which means 56 raised to the power 2 will be, the last two digits will be simply 36. So let us solve more questions so that we know that we are clear. 113 raised to the power 2. This can be written as 100 plus 13 raised to the power 2. So the last two digits will be the same as the last two digits of 13 square. So whenever you have 50 plus something or 100 plus something or 50 minus something or 100 minus something, you just take this plus or minus this expression. 13 square is 169. So the last two digits will be 69. So 113 raised to the power 2, the last digits will be 69. And obviously, as you can understand, this you can try to make this as you will be using this in many questions in the later stages. Now 84 raised to the power 2. 84 can be written as 100 minus 16 square. Again, the last two digits of this will be the same as 16 raised to the power 2. 16 raised to the power 2 is 256. So the last two digits will be 5 and 6. 5, 6. 37 square is 50 minus 13 raised to the power 2. Last two digits of this expression is the same as last two digits of 13 raised to the power 2. 13 square is 169. Again, the last two digits being 69. So whatever numbers you are given, if it is a square, you express this in terms of 50 plus something or 50 minus something or 100 plus something or 100 minus something, and the last two digits of this number will be the same as last two digits of x square or y square. So I hope the examples make it clear. Okay, now let's look at the numbers ending in 3, 7 and 9. Till now we understood the numbers ending with 1. So numbers ending in 1 was very simple. So in this case, all you need to do is to convert this 3, 7 and 9 into a number ending in 1. So what I mean is, first you need to know that 3 raised to the power 4 is 81. So if you have any power of 3, that can be expressed as some power of 81 maybe, in which case 81 will end in 1. Similarly, 7 raised to the power 4 is 2401, again ends in 1, and 9 raised to the power 2 is 81, ending in 1. So I'll be showing this to you in examples, but basically you need to remember at least this much. So whenever you have 3, 7 and 9, you need to remember 3 raised to the power 4, 7 raised to the power 4 and 9 raised to the power 2 give you units digit ending in 1. You don't even need to remember these entire numbers. So how do we use this? So let us say I'm trying to find out 69 raised to the power 64. So as I said, in case of 9, first you need to remember that 9 square gives you a number which ends in 1. Obviously we know it's 81, but I'm just showing this to you so that to tell you that you don't need to remember. Now 69 raised to the power 64. So this means because I need a 9 square here, so let me write this as 69 raised to the power 2. One second, let me just write this more clearly. So this is 69 raised to the power 2, the whole raised to the power 32. That is how we can write 64. Now in this case, first we need to find out this number. So this is step number 1. Now in step number 2, I'm just looking at 69 raised to the power 2. Now I told you whenever you have a square, you express this in terms of 50 plus minus something or 100 plus minus something. This, as we all know, is equal to 50 plus 19 raised to the power 2. So the last two digits of this will be the same as last two digits of 19 square. 19 square is 361. See, you need to remember the squares of numbers up till preferably 25, but at least 20. Otherwise, you will take more time in the exam to find these questions. So 19 square is 361. So the last two digits of this is 61. So I know that 69 raised to the power 2, the last two digits will be 61. So I know that this is a number of the kind x, y, z, let us say whatever, 61 raised to the power 32. This is what I know. Fine. So this is good enough for me, because whenever we have a number ending in 1 and we are trying to find out the last two digits, all we need to do is we need to take the tens digit multiplied by the unit digit of the power. 6 into 2 is 12, that is 2, and the unit digit will remain 1. So the last two digits of this expression will be 21. That's how you do it. Now let's take another example. This is more complicated. So if you're able to follow this, this means you have understood whatever we've been talking about in the videos till now. So I have 87 raised to the power 474 and I'm asked to find out the last two digits. Again, you need to remember that 7 raised to the power 4 ended in 1. So this is all I know. So now firstly, let me just divide the power by 4 to find out whether it is divisible, what is the thing. So 8, this is 32, so the remainder is 2. So which means 474 is simply 118 multiplied by 4 plus 2. So this is how exactly I'll write this exponent now. So this will be 87 raised to the power 118 into 4 plus 2. Now if I solve this, I'll obviously get 87 raised to the power 4, the whole thing raised to the power 118 multiplied by 87 raised to the power 2. So when I'm trying to find the last two digits of this expression, it will be the last two digits of this thing multiplied by the last two digits of this thing. So let's try to understand what we have here. We have 87 raised to the power 4 raised to the power 118 into 87 raised to the power 2. Now as I told you, this number will be ending in 1. So this number, I'm just trying to explain it to you first. 87 raised to the power 4 will be some x, y, z into some number here which we'll find 1. Right? This whole number, this I am writing x, y, z because I don't care about these numbers. I care about this number. Something will come here, raised to the power 118. So this expression, I can find out the last two digits of this whole expression. This, now I have multiplied by 87 raised to the power 2, I can find out the last two digits of this expression. So if I have last two digits of this and last two digits of this, I can find out the last two digits of this whole expression. So let us try to find exactly that. So first let me try to find out this xyz something into 1, and I need to find this something into 1. So let me try to find out the last two digits of 87 raised to the power 4. Now I told you that this is 87 raised to the power 4 is 87 raised to the power 2 into 87 raised to the power 2. Now I told you that whenever you have squares, the last two digits of 87 raised to the power 2 will be the same as, if I can express this as 100 plus or minus something. Now 87, as you know, is 100 minus 13. So the last two digits of 87 raised to the power 2 will be the same as the last two digits of 13 raised to the power 2 into this again is 13 raised to the power 2. This we know is 169 and this is 169. So again I just need to take the last two digits. Last two digits will be 69 into 69. Now this is what I have. So again I need to find out the last two digits of 69 square. But again I have the form of a square. This again I can write as in terms of 50 plus or minus something. 69 is equal to 50 plus 19. So last two digits of 69 square is the same as last two digits of 19 square. Now as I told you, you have to remember the squares up till 20. 19 square is 361. So the last two digits of this are 61. So what I find out was that 87 raised to the power 4. 87 raised to the power 4 is something x, y, z into and 61. This is how this number looks like. So we just found out this. So now this whole expression becomes x, y, z 61 raised to the power 118 into 87 raised to the power 2. Now again I need to find out the last two digits of this and last two digits of this. Now last two digits of 87 square we already found out. 87 square will have the last two digits of 87 square will be the same as last two digits of 13 square, which is the same as 69. So this I already know as 69. So last two digits of this is 69. What about this? Whenever you have an expression of ending in 1, I take the tens digit of this number and the unit digit of the power and multiply them. When I multiply them, I get 48. So this is 8. 48, I ignore the 4, put in 8, and because the unit digit of 1 raised by anything will always be 1. So this is the last two digits of this entire expression multiplied by 69. So you can solve this now easily. When you multiply this, you get 5589, which means the last two digits are 8 and 9. So for this entire expression that we saw, this thing, the last two digits are 8 and 9. That's the answer. So if you followed all the steps of this question, please do this question again yourself or just rewatch the video to make sure that you've understood all the steps. If you have, it involves most of the basic concepts that I've covered in the videos. Okay, now after this heavy duty dose of calculations, let's go to something very, very simple. So numbers ending in 5. 5 used to be my one of the favorite numbers because it's very simple. 5 raised by any power is 5 and it has many other nice properties. So anyhow, so now I'm trying to find out the tens digit. Because the unit digit will always be 5. Now if I have powers like this, as you can see, how do I find out the last two digits? It's very simple. Just check the tens digit and the exponent, that is the power. If both of them are odd, then this entire power will end in 75. Else it is end in 25. So what do I mean? Firstly, that in case of powers of units digit 5 and raised for any power, the last two digits can either be 75 or they can be 25. There is no other option, and it is 75 only in very few cases. In most cases it is 25. What are the few cases? That is the tens digit of the number and the power are both odd, means the last two digits will be 75. So now what do I mean? Let's just see some examples. In this case, the tens digit of the number is 3, odd, okay, and the power is also odd. So the last two digits of this number will be 7 and 5. Fairly straightforward. Now let's move here. The tens digit of this thing is even though the power is odd. So because one thing is even, this thing will end in 25. Okay. Again, this thing, the tens digit is even. So whenever one of these things is even, it will end in 25. Now here, this is even and this is odd. Again, 25. So now if I give you something like 1575 raised to the power 547, you would know that this is odd and this is also odd, will end in 75. Similarly, if I give you 1455 raised to the power 462, this is odd but this is even, end in 25. So whenever the tens digit and the exponent are both odd, it will end in 75. In all the other cases, it will be 25. Fairly simple. Okay, now we are edging towards the end of this concept. Now if we have numbers which end in 2, 4, 6 and 8 and we are trying to find the last two digits of an exponent, then how do we do it? Firstly, you have to remember something very simple. 2 raised to the power 10 raised to the power of an even number will always end in 76, and 2 raised to the power 10 raised to the power of any odd number will be ending in 24. So first you understand this concept because this will be used in many questions. So I'll take an example. Let us say I have 2 raised to the power 543. Now this I can write 543. See, it's raised to the power 10. So I have to write this as some multiplication of 10 plus something. So this will be 554 into 10 plus 3. So now when I open this, I'll get 2 raised to power 10 raised to power 54 multiplied by 2 raised to power 3. You should be very easily be able to get this expression. If not, then you need to basically revise your exponents a little bit. Okay, now I told you that when it is 2 raised to power 10 is raised to an even power, this thing will be ending in 76. So this number, the last two digits is 76. This last two digits are 0, 8. So if I multiply this 76 into 8, I get 608 and the last two digits are 0 and 8. So this is a fairly simple rule. Now, but we will be using this in various questions. To show you an example, again this is one of the most difficult questions of the video series. So if you are able to follow everything that I am telling here, or you are, the best would be to please pause the video and do it yourself. If not, if you're able to follow exactly what I'm saying, then you've nailed this bit. Okay, so we are finding out the last two digits of 34 raised to power 236. So 34 raised to power 236 can be written as 2 into 17 raised to power 236, which is equal to 2 raised to power 236 into 17 raised to power 236. Okay, because 2 raised to power something we know how to find. So now 2 raised to power 236, this entire expression I can write as 2 into 10 raised to power 23 into 2 raised to power 6 into 17, because as I told you 17 raised to power 4 is 1. So this is 17 raised to power 4 into 59. If you see, 59 into 4 is 236. So that is how I am writing this. So this is what I need to find out the last two digits of. So I need to take the last two digits of each of these things and multiply them to find the answer. Now 2 raised to power 10 raised to power something odd. If it is something odd, the last two digits of this expression will be 2 and 4. 2 raised to power 6 you all know is 64. Last two digits 64. Now this is the only thing that I have left. So let me just take this here and find it out, and I'll plug this in there. So I have 17 raised to power 4 raised to power 59. So this is 17 square into 17 square raised to power 59. So 17 square is basically 289. So this is 289 into 289 raised to power 59. Now I need to just take these two last two digits. So I don't care about this, the 2 number. So this is equal to 89 into 89 raised to power 59. So the last two digits of this whole thing will be the last two digits of this thing. 89 again is 100 minus 11. So the last two digits of this thing will be simply last two digits of 11 into 11 raised to power 59, we'll see. So this is raised to power 59. This is 121. So the last two digits of this whole expression will be again x, y, z sum 2, 1 raised to power 59. This is what we have found out till now. We haven't touched 59, but 17 raised to power 4, or you can even multiply because it's fairly simple. But I'm just saying this is, you just take the last two digits and you keep finding this out. So this is 21 raised to power 59. Now when I have this, I just take the tens digit of this and the units digit of the power. So this is equal to 18. I just forget about this 1 here. I'll take 8 and the last two digits of this expression is 81, because 1 is here, 1 will go there. So this is equal to this. So now the last two digits of this entire expression is 24 into 64 into 81. So if you multiply all of these, you will find the answer to be 124416, and 16 are the last two digits of this entire expression. Now in the exam you don't need to exactly do all these calculations. So I'll tell you, so let me just remove this from here once, and now let me try to find out just to show you how to do it quickly in the exam, because you'll all have your own styles, but this is how you can work with it. So I'm trying to find out the last two digits of 17 raised to power 4 raised to power 59. So this is what I need to find out. So this is 17 square into 17 square. So again 17 square is 289. Forget about the 2. That is 89 into 89. 89 is 100 minus 11. So this is the same as 11 into 11. That is 121. So last two digits 2 1. So this is simply something x y 2 1 raised to the power 59. So 2 into 9 is 18, 8 and 1. These are the last two digits. So I just showed you how you can do this quickly. Now again, when you need to find, let me forget about this product here. So this is what I have, 24 into 64 into 81. Now you do 24 into 64. 24 into 64 is 1536. Into 81, I need to find out the last two digits. Again, I don't need to multiply the whole thing. Just take the last two digits of this and last two digits of this. So I just need 36 into 81, and this product is equal to 2916. So my last two digits are 16. So this is how you need to do it quickly. Please, whenever I am working in these videos, I am trying to show the whole process so that you are very clear with the entire steps that are supposed to be followed. Obviously, it doesn't mean that you have to do all these steps. With practice, you will see that a lot of these steps are only for understanding, and you will be able to solve these questions very, very quickly. Okay, thank you.